Okay, so we are live right now. Hello, everyone.
Good evening.
So first of all, we're very sorry. We were supposed to start the live at 5, but there was some technical glitch. But we'll be starting with the live again. So I'll just give a brief introduction. My name is Aditi, and I'll be your host for today's live session. Thank you all for joining in. And for today's weekly career class, we will be talking about careers in the booming semiconductor industry. And to talk about that topic, we have with us two guest speakers actually, Sharat Kaul and Jayachandra Aradhya. So, hello, sir.
Yeah, good evening.
Okay, I just give brief. And Sharat sir is an accomplished professional with impressive career spanning leadership roles at notable companies like Krypton Solutions, IESA, Moschip, and Solar App Energy Private Limited. His expertise lies in establishing operations, driving strategy and innovation, business development, and achieving consistent growth across various domains. With an MBA from SMU Cox School of Business, a BSEE from a University of Texas at Dallas, and a Bachelor's of Science in Electronics from Bangalore University, Sharat combines technical proficiency with strategic vision and leadership skills. Welcome to the live, Sharat. Thank you for joining us.
Thank you, Aditi.
And Mr. Jayachandra Aradhya is a visionary speaker and thought leader who inspires audiences on innovation, entrepreneurship, and master, which is maths, arts, science, technology, engineering, and robotics implementation. As the CTO of Elfonze, an ESDM company, he drives technological advancements and champions sustainable innovation to make India self-sustainable and globally competitive. Welcome and thank you for joining us today, both of you.
Thank you very much.
Thank you, Aditi.
Okay, so before we start the live, if whoever are watching us, if you have any questions, please don't hesitate to use a live chat to ask your questions, and we'll be taking up all the questions towards the end of the live. So we can begin with the session, sir.
Sure. A very good afternoon, young students, the future generation for our country. I hope everyone can see the slides. These are the topics we'll be covering today. We are trying to explain what are semiconductors, what do semiconductors engineers do. I will be touching upon the future of semiconductor industry and whether there's been success. And I'll be sharing this section with my colleague, Mr. Aradhya ji, who will then be going in and talking deeper about how to become a semiconductor engineer. And then we'll finish with emerging career paths, and hopefully we'll have some time for question and answers at the end. So what is a semiconductor? A semiconductor is exactly what it says. It's a semiconductor. It doesn't have the properties of a conductor, such as a metal, and it has an inverse property, which basically means that the resistance, the ability to flow current reduces as temperature rises, which is the opposite of a metal. And this inherently has advantages so that we can control the flow of current through a semiconductor. So Robert Noyce invented the first monolithic integrated circuit in 1959. And that picture on the left shows you how they were able to do a proof of concept and get current to flow through a semiconductor material. The chip was made from silicon, and the idea was to create a ceramic substrate, so basically an insulator, and through the insulator to be able to control the flow of the current. And basically what this is a switch. And how do you control a switch? Now, if you fast forward today to 2024, there has been extreme amount of innovation over the last 30 to 40 years. And what we're basically doing is reducing the size of that picture, which I showed earlier, smaller and smaller and smaller and smaller over the years. And what we call these are technology nodes. This is nothing but the front end manufacturing of a semiconductor. And this has dramatically made the performance of these semiconductor chips become so fast, and the power has become so low that we're able to put them in the smartphones that we use today, like iPhone, etc. And it's revolutionizing the way we're doing computing today. By virtue of even doing this video call, it uses semiconductors. So I showed you the picture of a 1959 semiconductor, the very first integrated circuit. And today we're at 3 nanometers. And this is a picture of a 3 nanometer chip. And this has billions of transistors, all packed in the size of your fingernail. And 3 nanometer, for the young minds on the call today, is approximately the width of 3 atoms. 3 atoms. So the size of these transistors has become so small that it's at the atomic level. And we are now able to control the current at a width of only 2 to 3 atoms. So the current has to be very small and the voltage has to be very small. And if the voltage and current is very small, therefore the power is very low. And that's how we're able to get the long battery lives on our mobile phones and the long battery lives of our laptops, battery applications. The semiconductor engineering field is very vast. We have careers in front-end manufacturing and back-end manufacturing. We have careers in the end product. After the product has come after manufacturing, there's many semiconductor jobs. There's many semiconductor jobs involved in the design of the chips using software. After they've designed it in software, it goes to the manufacturing and then back-end manufacturing into the package. All of this is the semiconductor industry. And Aradhya ji will be talking about what Elfonze does and how we are focusing on connecting the semiconductor chips to the actual real world. So I won't go into a great amount of detail, but this gives you a very high-level picture of the manufacturing portion of semiconductors, not the embedded. This is what we call VLSI, very large system integrated chips. And this is all the foundries. So basically, all of these logos that you see here, companies that you're very familiar with, Qualcomm, Apple, NVIDIA, Samsung, NXP, you would have heard about these companies. They're all involved in front-end manufacturing and design. And all the semiconductor jobs are available for these companies. And they're urgently trying to hire students like you when you graduate, and they want to get talent from India. So all of these companies are global companies. They're all over the world. They have design teams all over the world, manufacturing all over the world. Semiconductor is truly a global industry. And I want to give you one interesting fact. All of our mobile phones and battery devices are controlled with microprocessors. And in order to that microprocessor to go from design to our product, can you believe it? It has to touch 44 countries, 44 countries before the end product is available to us. So that's how the entire globe is interconnected for semiconductors. This picture shows you the value chain. So at the bottom of the pyramid is where we're doing the design of the chip. And then we integrate the design with off-the-shelf blocks. You would have heard about USB. You would have heard about HDMI. Your TV at home has a USB port. Your laptop has a USB port. Your mobile phone has a C-type USB port. These are all blocks, pre-made blocks, which the semiconductor engineer has to stitch together and make them talk to each other. And they should not have any bugs. They should not, the speed should be all in sync. Then once the chip is designed, it requires specialized materials to go into what's called front-end manufacturing. And those are the silicon wafers. The silicon wafers, then we have a whole number of companies that are only doing design, and then we have companies that are only doing manufacturing. Those design companies hand over the design to the manufacturing companies, and then it goes to create a semiconductor wafer. This wafer is then cut up into small little the size of your thumbnail dies, they call them, DIE. And then those are in turn put inside of packages. And then the packaging are then in turn put on the development boards. And the development boards are what feeds the applications like mobile phone, airplanes, our cars are becoming more computerized. And we'll be going into more detail, but this is the entire value chain. Semiconductor careers are in this entire ecosystem. So what's the future of the semiconductor industry, and is there success in this industry? And the answer is a big yes. The recent reports have shown that 22 to 23% of global revenue, global business, is coming out of the digital economy, which is all powered by semiconductors. In 2020, the value of the market was around $4.4 trillion or $400 billion. And by 2035, it's expected to cross $1 trillion. That's 1,000 billion dollars. And so that's 80,000 billion rupees is the market. Another report is suggesting that by 2031, it'll reach the embedded market alone, which is after the chip is manufactured, after it's in the end package, and after it's on the board, and it has to go into the end applications like we showed you, like aeroplanes, like mobile phones. From manufacturing to the end product, they're estimating that market to be $163 billion by 2031. And the government of India, through its Make in India scheme, Atmanirbhar, has suggested that the gross domestic product, that means the amount of business that it'll represent of India, will be 5% by 2022. And it's going to create 100 million new jobs by 2028. So in 2028 is in 4 years' time. Many of you will be entering your college, so you must be considering this highly advanced technologies and the exciting careers in semiconductors. We won't spend too much time, but embedded systems that Aradhya ji will be talking about covers a vast number of applications and systems. There's expected to be 7.5 million embedded engine professionals in the world. Opportunities are there on the hardware side of embedded and the software side, which we're going to go into more details. And the research and development for semiconductor engineers is estimated to be 200 billion US dollars. And India is expected to be 1/4 of that at 50 billion. And there are absolutely diverse opportunities, and there are specific Indian solutions that are required from bright minds like you to create indigenous applications for the Indian market that in turn can be used for the global markets. Example, India has UPI, those are all powered by smart devices. India had done COVID vaccination. The platform is all done on the semiconductor devices. We have to do computing for India's challenges like landslides, like earthquakes, like etc. That requires computing. Satellite communication requires computing. ISRO needs computing. Our DRDO needs computing. Our defense systems, our avionics, our HAL, all need semiconductor components, and needs the gap between the availability of trained engineers and what we require in the industry is very huge. And it's very important that more and more bright minds like you are coming and taking up semiconductor as a career. This is a table which shows the expected number of headcount that the government of India has projected is needed by 2027. 85,000 people, and of which 20,000 is purely on chip design. Or I beg your pardon, that's in 2027. 68,000 of the 85,000 is only design of the semiconductor chips. And then the remaining 10% and 10% is in the front end and back end manufacturing. So 20% is expected to be manufacturing jobs in the fabrication facilities and the packaging facilities, and then 68,000 or 80% is expected to be purely design. This is the evolution of the industry in India. Level 1, we mostly outsourced the development, leveraging low-cost labor in India, and it was based on contracts. But then as we matured, Texas Instruments, AMD, and these large MNCs started establishing development centers, which you must be seeing all over Bangalore, and now that's growing to Noida, Hyderabad, Odisha, Chennai, and even to now other cities across the country. And instead of having only contract-based work, now it's on task level ownership and augmenting teams from the headquarters that basically They're all working together on different parts of the chip at a global level, leveraging the different time zones, leveraging the different expertise. And now we're at level 3, where actually the specification and the entire product development is now happening in India. And now India is becoming so advanced because of our experience. Those blocks which I was talking about, like USB, PCI Express, Ethernet, etc., are now being developed in India. And end-to-end solutions are being created in India, which means that more and more startups are starting to come from this engineering talent, and more companies and more end-to-end product development is being done. So with that, I'm going to conclude my section of the section and hand it over to my colleague, Mr. Aradhya ji. He'll be talking about how to become a semiconductor engineer.
Thank you, Sharat ji. Wonderful presentation on a real estate technology. So yes, as Mr. Sharat has explained, see, there are 2 parts in any of the semiconductor industry. One is actually on the VLSI, that is IC chip design. So once chip design is done, actually, now the next one is more on embedded system. That is more of applications creation after and from the chips, whatever it is designed. Okay, now we are coming to the application, more of applications. So, see, I think students, you are aware of the Mars mission, and as well as rovers are used in the Mars mission, correct? So how it is designed, if you go through that actual design, there are many parts, many of the electronics components, equipments are used in those. So in fact, actually, there are many computers was there, and instruments was there, sensors, communication system, power system, navigation system, heat management system, data storages, processing, entry. See, there is landing systems and all those things. It has got a lot of electronics parts built into that. In fact, if you go through that exact the specification and feature set, okay, it is more designed to for the toughest environment in the Mars. So this is what actually the valuable scientific research has been conducted using electronics part. Okay, so this is what the one of the example I want to start with that, because you will be more excited to that. See, as you know, actually the autonomous vehicles are coming out, and already the many vehicles are already implemented more of electronics into that, like ABS systems, or even it is more of electronics part like communication systems and your auto guiding systems, mirror setting systems. All it is all is everything. It is electronics. As you know, actually the one car manufacturer. What is the how many microcontrollers are there inside? Okay, it is not one chip. It is 22 chips. Actually, it is controlled in a whole electronic system of a car. So now the future is going to be a black box. It is going to have one controller, which is going to have control of almost all your systems in automotive. Okay, that's what actually we are more excited about. I think you're already aware of Tesla, who is coming with fully autonomous vehicle, which is no driver required. So it is it's electrical system with pure on automotive, automatic. It has a adaptive control, lane keeping assistant, and automatic parking systems. Everything is built in. I think you will be I think your generation will more enjoy on this system, correct? Okay, let us see next one. Yeah, so I think already we are seeing Sharji explained that chips are used in any of the electronics equipment. Okay, now we are talking about electronics equipment or a component or equipment or even tools. So mobile is one of that major application, which is earlier the mobile system and the latest system. It is coming on the more of a smarter system. Okay, which is everything. It is now camera is taken inside, the clock is taken inside, and your compass is taken, calculator is taken, everything it is built in as a part of the software inside this hardware. So to do that, actually, it does need a low power devices as you required. Okay, so that's where actually the new innovations are coming out. And as you know, actually the medical equipments, see, most of the doctors are using all medical equipments. Actually, they are all becoming engineers. In fact, engineers are becoming doctors by knowing more and more about medical equipment, medical system, medical terminologies, and doctors are becoming more of engineers now. Okay, so let's go next. Okay, and consumer electronics, I think most of the things you're using already at home. Every equipment has got electronics inbuilt in. And most of the now automotive manufacturing companies or any of the manufacturing, so that has got robots. Even robots are controlled using electronics component or equipment. So to do these designs, okay, so there are a lot of things are required. Input and output devices. There is a passive and active components we are talking about. Let us see what is next. Yeah, please. See here, when we're talking about embedded system, okay, there are more of applications. If you see home appliances or heating system or GPS system or fitness tracking or medical equipment or factory robots or electrical vehicle system, interactive kiosk, banking sector or automotive sector, everywhere the embedded systems are, I know it is more of applications on embedded systems. Let us see the next one. Next. See, even I think every equipment is becoming more and more intelligent and smart. Even your like AC or in a washing machine, it is controlled through your mobile phone, correct? So even your temperature control can be controlled and monitored, and as well as the temperature also, like if you want, as soon as you go on your bed, actually that whatever the temperature you want to maintain, and after 2 hours or 4 hours, you can set the temperature. So that is also possible. Even actually on your washing machine, depends on the cloth used, depends on the timing of the water, everything, it can be monitored. Yeah, please next. Yeah, coming to the next, more of real world embedded systems. Okay, see here, even your coffee vending machines, or it can be a ABS system, as I mentioned in the automotive, and your network applications or mobile services with more of a lot of smart communication, internet browsing, and multimedia playback. All is in your soft electronics part. Let us see next. Yeah, when it comes to electronics as a design, okay, we have a lot of test points or consideration points actually while doing design. If I want to design a mobile, what are the things has to be considered, or when I'm designing automotive embedded product, actually what will be my priorities? Most of the parameters will be on the safety or a cost sensitive or a performance, reliability, time to market, unit cost, everything it has to be considered. If I'm considering the automotive, you can see that all this in high priority. When it comes to mobile, actually there'll be a sum of cost is more sensitive than any of the other. Like if you go with time to market, it is very less market. When the less time actually to be used means as soon as you design a product in the your mobile, so it, within next 3 to 6 months, there will be a new additional features and specifications, right? So before that, you need to market that product. Otherwise, it will be there'll be a new competition from new vendor also, right? So that is what actually, see, when you consider all these 6 parameters, any of the embedded devices or equipment will be designed. Next. See, usually, if you see that any of the equipment, embedded equipment, it will be more of architecture is like this. Okay, this is there will be a analog signal and there will be a digital signal. Okay, and as well as the same thing like analog to digital conversion or digital to analog conversion, it is supported with the memory and the FPGAs and as well as software. Here, actually, if you see that there will be a sensor and actuators to interface any of your hardware system, and the software is a major one actually which sits on any of these embedded systems. If you see in embedded system also, there are 2 parts. One is the hardware design and one is the software design. But even to become a software engineer, you have to it is mandatory to know about the hardware part of it. Yeah, please next. This is an emerging career. Let us see that. Okay, so why is embedded as a career? Okay, there is a lot of, as Mr. Sharat has explained, there is a huge demand is going to come worldwide, and as well as India is emerging because of the government, a new initiative to make in India and made in India. So there'll be a huge skill shortage and need of quality engineers, in fact. So even though you go by your in electronic system, you need to be very strong in the basics. Okay, but once if you have become an embedded engineer, it's high paid positions in the industry. Yeah, we'll go this. Yeah, the qualification required. So even though we talk about ITI diploma engineering, to be in electronics as an embedded engineer, okay, you need to be a electronic engineer, electronics and communication engineering. You need to take it, or electrical and electronic engineering, or electronics and instrumentation engineering, or mechatronics. Okay, see, and when in your city there'll be definitely there'll be a lot of engineering colleges. While selecting the your sector or a discipline, you have to be very careful. You have to select electronics and communication engineering the first priority, and after that any of these other three parameters. I mean the three departments. But opportunities are as a to be an embedded. These only four departments can give more skills actually to be in the as an embedded engineer. And opportunities local and as well as global market. Beyond the academic syllabus and curriculum, students need to learn all the skills required and understand the basic electronics and design aspects to the requirement. Also, these engineering colleges or diploma or ITA colleges, whatever they teach in the academically, you need to learn. In addition to that, there'll be a see. Usually, any colleges will train you on the basics. Okay, it's only a platform. In addition to that, actually, to be in the design field, you need to go to any of the private institution or any of the additional courses which is available in the market to be in the field. Yeah, please. Thank you. Next. So that's what I was talking. So the ITI diploma in engineering. So diploma also like they can become a technician and technical support and quality control. And if it is an ITI, then they can become an assembly section technician or service technician. Next. Okay, as an engineer, you will have opportunity like a design engineer, embedded system design engineer, power electronics engineer, control system engineer, renewable energy engineer, instrumentation engineer, automation engineer, and calibration and test engineer. So that means, so it is not only the electronic engineer, it is in addition to that, actually, once you get it into a specialization or in one of the domain, you will be called as a particular based on the domain expertization, you will be called as an engineer. Yeah, please. Okay, see what so what need to be studied in electronics or electrical or instrumentation to be in the design aspects. Okay, one is C++ and Python and basics of electronics, and any one of the any 2-3 controllers, like there'll be 8-bit microcontroller, a 16-bit or 32-bit microcontroller with RTOS, and there'll be one more is there are some communication protocols you need to understand, and you need to learn any of the problem solving and debugging skills. Okay, so this makes you actually to be in the embedded field. Yeah, the last 3 slides actually I want to give you on future of embedded engineer. So once you become an embedded engineer, there'll be a different industry will take you for the design and as well as manufacturing process. One is the IoT and automotive industry, artificial intelligence, machine learning. Okay, see when it IoT means actually see anything on a smart homes and smart cities, all these managed by on IoT features. So next please. See robotics, healthcare and medical devices. I think I already covered all this, but just I want to give you a glimpse of future of engineers by next 8 to 10 years, because you're all in high school. So once you come out of this and when you join engineering, and when you come out of the engineering, you will be working any one of these advanced areas. Smart cities and infrastructure, defense and aerospace, which is India is more of avionics product development. So please next. Consumer electronics. So consumer electronics, again, there will be a national and international level of product development and energy and renewable sources, industrial automation and control. Okay, any of the manufacturing company, this needs electronic support. Okay, but along with that, actually, if you want to be in any of these field, you need to learn mechanical also. So that means you have to be a mechatronics engineer to become a product design engineer. So in embedded, it is not only the hardware and software. You need to learn the product design as well as. So that means actually you need to know the mechanical design, product design, then prototyping of the products. So all you need to learn. So for that, from today onwards, you can be as a more of a design, more of a creative, more of innovative in electronics field. And also any of whatever you think, actually the problems, wherever the problems you find, always think of coming out of solution. Please note down those problem statements and keep that, you always discuss with any of your seniors and teachers and faculties, so that you will get some idea about actually how to come to the stage of wherein you can give some solution. So if that is if you get some idea, then there'll be a lot of opportunity you will get in future also to solve that problems. Okay, so this is anything you think of electronics. So embedded is important. Anything think of electronics, VLSI is very much important. So VLSI and embedded hand to hand are always more of chip design to then application design. Okay, thank you very much. Next, please. So thank you very much. If any questions, I'm going to take it up.
Thank you. Thank you, sir. We do have a few questions. I think one of the questions we've already covered. So the first question that we got is, what is the future prospect in the semiconductor industry? And if you would like to add a few points, and we can add, otherwise we have covered that. I think we've covered that question. But if you would like to add anything, you can add.
Go ahead, Aradhya ji. Aditi, could you just repeat the question, please, one more time?
Yeah, sure. The question was, what is the future prospect in the semiconductor industry?
So there's expected to be about 100 million new jobs by 2028, and this is divided into design and manufacturing. And as I mentioned to you, 85,000 is the goal of the government of India, of which 80% is design and 20% is manufacturing. We already have around 1.25 lakh design engineers in India today, and manufacturing has just started. The students would have seen the recent announcements probably of the developments in Gujarat and the Fab cities and Micron and Tatas. But if you Google, you'll see a lot of investments are coming. Now, all of these investments are going to require skilled engineers. So the opportunity right now, the demand is so huge that we don't have enough people. Most these students are going towards other fields other than ECE and electronics and embedded. And as a result, there's a huge gap of talent. And the salaries of VLSI and embedded, although computer science also has good packages to start with, embedded and VLSI have equally good packages, but it is in fact that as you progress on your career, the salary and compensation of VLSI and embedded actually exceeds computer science, and it exponentially gets higher. And not only that, instead of the opportunities to be a global engineer and get placement in Europe, in Japan, and in United States becomes far greater, because they are also have a huge gap in their supply. And the demand is huge. They're building so many of these manufacturing facilities. You have to have designers, you have to have technicians, you have to have machine tool operators. And how will you fill these manufacturing facilities like China does, unless we start at the school level? I hope that answers the question.
Thank you so much. There was another question. So you like to add something?
Yeah, something. No, see, to meet this requirement, the government of India has taken one more initiative called Atal Tinkering Lab. That means actually almost about more than 10,000 schools been working on many of the embedded applications training program at school level itself. So they're given science and technology, that is STEM education lab setup at schools. So many of the schools already adopted this concept, and they are educating the school students on like basics of science and basics of electronics and building the IoT system, building electronics circuit design, and little bit programming also. So that means actually to motivate the students on ground level. That's what actually the government has taken initiative.
Okay.
The next question.
Yeah, we do have another question. The question is, what is the role of mechanical engineer in semiconductor industry?
Sharatji, can you take, or shall I?
You please take it, Aradhya ji.
Yeah. See, in semiconductor industry, the mechanical engineers are not directly on design part, but any of the semiconductor manufacturing or a design company, anything, you talk about, mechanical engineers are must. Okay, so even you take any of the equipment like automatic assembly system or robots or vending machines or anything, it is not designed by electronics engineers. It is designed by mechanical engineers. So it is only electronics is a part of that. Actually, we will be sitting on mechanical. So we'll be controlling your mechanical with the like hydraulics and pneumatics through our electronics.
Okay, thank you, sir. We do have another question. And the question is, what are the steps to begin with for beginners, and what are the scopes in India for this career?
So to begin, already I think it is, I mentioned that the STEM education and as well as Atal Tinkering Lab, it has already taken steps. And to add to that, actually, see, students need to join diploma or ITI or engineering. Okay, see, if you are taking an ITI as a career, then they'll become an assembly technicians and repair technician. Once if you are taking a diploma as a career, when a qualification or education, then you will become a mid-level, that is a technician, supervisor, technical support, and quality control. If you are an engineer, then you will have a lot of other opportunity of becoming a design engineer, embedded engineer, power electronics engineer, renewable energy, instrumentation, automation engineer. There will be a lot of scope.
Okay. I think that's all the questions that we had for today. So with this, I think we can wrap up today's session. And I would like to thank both of you, Sharat sir and Aradhya sir, for sharing your experience today and your journey with our audience. And I hope that all our students or anybody who's watching us got the answers of the questions. If you have any more questions related to your career that you need to ask or related to the topic, so can you put the QR screen slide? Yes. So if you have any more questions that you need to ask, you can just simply scan this QR code and it will take you to our web app, and there you'll be able to see an ask me anything option where you can get answers directly from our expert counselors. So just go ahead and explore, and don't forget to hit the subscribe button to not miss any weekly career classes. We do this every week, and thank you all for joining in. Thank you so much, sir. If you'd like to say anything.
Thank you, everybody. Thank you, Aradhya ji. Wish you all the very best.
Yeah, thank you. Thank you very much.
Thank you so much.